Real good. That's what I like to hear. Project in the can? Good? Good Facebook chatter. I like that a lot. I tuned in too late to be helpful this time. I tuned in this morning to be helpful with it. But,
that's useful.
Well, I tune in when I can. When I check Facebook, I'm like, blah, 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 and blah, 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 posted. I'm like, yay. And then I get in there. And usually by the time I check in, somebody has asked a question, 20 comments have been made, and the last one has figured it out. And that's just exactly what I want to have happen. And the work I saw was fantastic. And one of them was great because somebody asked a question based on a misinterpretation of what I asked, and it was all cleared up by the time I got there. So, and I think Alicia said, and as Sean will say, boom. And I was like, yeah, it was perfect. Boom, you guys figured it out. It was perfect. So, I'm glad that you guys didn't get crazily overworked with what you had to do with the last like 12 points.
Oh, we did.
F9 10 times, write down the values you get and average them. That was all you had to do. And I think this is again the problem, and again, the course is almost over. But if you skip right to the problems I ask you to do without kind of reading the stuff before it, it can be pretty overwhelming to know what you have to do, right? If you don't read like the stuff that before, at least the instructions, but also the stuff that precedes it. Because in the stuff that precedes it, what I did with those was, I ran simulations a couple times to show you what was going on. The project was 2 parts, like I told you. It was the super counting part, which was around the matter password. How about that time, huh? The amount of time it takes to crack it maximally. We have no idea how big these numbers are, or why this is taking so long to load. But we had, I mean, think about that number. It was what, 10 to the what power? 10 to the
26.
26.
And
that's years, right? Or was that
No,
seconds?
that's seconds.
That was in seconds. But even changing it to years, it was something like
7 to the 10th power.
10 to the 10th?
10 to the 10th.
So what is that?
years.
That is like tens of billions of years? Is that what that is? Is that right? 6 is millions, 9 is billions, 10 to be 10. I'm sure nobody changed it to
Why do
illions,
you
and
even
that's okay.
say that number?
You didn't have to. Yeah, 10 to the 10th is tens of billions of years. I mean, think about that, right? How old's the Earth?
415 billion. Oh, 455, give or take 10 billion years.
Wow! I didn't realize it was that many hundreds of billions of years. I thought it was tens of billions of years old. It's all good. Anyway, we're talking about age of Earth type of stuff here, yeah? And that's a computer cracking 100 billion numbers per second. Remember? 100 billion, is that what it was? Just 1 billion. But a billion numbers per second. Process that, and then process that happening for 10 billion years. And it's, I told you a story. I called Jesse. I know exactly, Faith. It's exactly right. Mind blown. I called Jesse. You're thinking about this, right? But now you're starting to understand the problem I gave you guys a couple weeks ago about the shuffling of a deck of cards. If you shuffle a deck of cards, there's a good chance you've never seen that shuffle before and it will never be seen again. You're starting to understand why now, aren't you? That shuffle is like a banner password. Essentially, is like a banner password. I mean, it's smaller actually. It's like a 52 orders, where a banner password has one of those God knows how many millions and billions and trillions of orders. But those numbers don't look very big, do they? 62 to the 15th, what is that? That's huge! That's ludicrous! It's so easy to write it down with exponents. There's an old story, I think it's legend, I hope it's not, but the inventor of the game of chess.
Yes.
Oh, that's still debated, yeah.
Yes, the inventor of the game of chess was a serf in one of these big, you may have heard the story before. Right? And the king who ruled, the lord of the land said, I want to thank you for this wonderful game that you have given us to take our mind off the real problems of the world, like paying you a fair wage. So what would you like? And the serf was genius. He said, simple. I would like a grain of rice on the first square of the chessboard.
And then
2 on the second. 2 on the second, and then 4 on the third, and then 8 on the fourth, and the Lord waved his hand. It will be done! And the serf walked away, chuckling to himself. Because by the end of that board, you've got 2 to the 64th grains of rice on the chessboard, on just one square. What is 2 to the 64th? It's a number so big we can't even put it in your TI and figure it out. 2 to the 64th power is ludicrous. And remember, the one right before it was 2 to the 63rd. And the one before that was 2 to the 62nd. And you guys in 105 may, depending on what year it was, may have done it. What is it? 10 to the 19th power. Holy poop. Now, if you ever get a chance to work a summer job, did you guys in 105 do this problem, the summer job problem? I might not have. You did it. Some of you did, some of you didn't. Depends on when you took my 105 class. go in, if you get a chance to like choose your salary, try this one. Walk in and go like, you can pay me $1,000 an hour. And after the boss's jaw gets off his desk, I got a better idea. Pay me a penny on the first day for taking the job. Pay me a penny right now for taking the job. First day I work, pay me 2 pennies. I'll work through lunch. Next day I work, give me 4 pennies. Next day I work, give me 8 cents, then 16 cents, 32 cents. And just keep that going for like the month of July. I'll even work weekends, and the 4th of July. I'll work all 31 days. And get him to sign a piece of paper that says he'll do that.
And get
It ends up being trillions of dollars, if I remember correctly. I can't do it in my head. Because the exponential growth of that amount is so ludicrous. Now, you would bankrupt that dude. Now, what you just did in your project is super exponential growth. Because you weren't just multiplying by the same number, you were multiplying by a number and then one bigger and then one bigger and then one bigger. So you end up getting these explosions of growth. Which is why I love that project so much, because it does blow your mind when you sit down and start thinking about it. It also brings back the reference of how big these numbers are. The illion problem that America has. We often hear our politicians using the illion words, whether it's million, billion, or trillion. Soon to be quadrillion. Your kids and mine are going to be dealing with that stuff. But it makes you pay attention. When I hear a politician goes, we spent so much money, $1.2 million, I'm like, get your shorts out of your crack and let's spend some real money on the problem. Because over there, you said, and if you watch the news long enough, you will see them contradict themselves. They'll talk about $1.2 million being an impossible price to pay, and then they'll mention $3 and $4 billion being water under the bridge. Like, wait a minute, that's 1,000 times more than what you just talked about before. And now it's water under the bridge, but before it was a problem. And their biases start coming out, because the 1.2 was to help the homeless, and the 3 and 4 billion was to bail out some politicians' lawsuits or whatever. So pay attention to those things. That's why I love this project so much, number one. Number two, the other part is the Monte Carlo simulations, and that second part. I mean, seriously, guys, to figure out what's the chance of drawing a flush sitting 2 to the dealer's right, or whatever the hell that one problem was, you cannot do that. Like, that problem cannot be done mathematically. It can only be done the way we just did it. Isn't that rad? Please, Davidson.
How long did it take you to write that program on Excel?
It depends on which one you're looking at. I actually stumped the IT department for one of them. The one about the shuffle, that one didn't. The Texas Hold'em wasn't that bad. Did anybody explore the sheets to look over where my random numbers were happening in those sheets? They'll be up forever, so you can always go back if you have time, if you want to do it. Scroll to the right and you can see the random numbers I was using to generate the decks of cards and the songs in the iPod and the burritos and the Taco Bell one and things like that, right? That was a fun one.
That one maybe.
So not very long for those, because those are fairly straightforward. The one that was the trickiest was the shuffle, to make that one look seamless. So I asked all the IT, I couldn't figure, I asked the IT guys, I'm like, here's what I want to do. And they're like, poop, we have no idea either. And I finally figured it out. If you get a true shuffle in 10 songs, that means you won't have a mode. Remember what a mode is? A mode means you have more than one occurrence of something. So what I did was I had it look at the 10 numbers, and I ran an if command. If there's a mode, you won't get an error. But if there's not a mode, you will get an error. So I said, if you get an error, that means it's a shuffle. Otherwise, it's not. I remember Peter Casey walking up to me and going, Rule, that's pretty good. If you don't know Peter Casey, that's like the Pope blessing you. That's like getting a blood Dominus Dominus from the Pope. I mean, seriously, like Peter Casey, head of the IT department, head of the CIS department, sounding like, you did a pretty good job. I'm like, feel a little taller today. I love those. I love doing Monte Carlo simulations. You'll see, I think we're done with them in here, unfortunately, and you'll see why we're done with them soon. Although you are going to see one from OMSI in a moment with Max. But Monte Carlo simulations, running data to collect results of experiments, it's the way statistics is done most of the time in the world. That's what I've been trying to move 243 and 244 into. And so many of the kids that I've then trained to become actuaries thank me for that, because when they go to become actuaries, that's actually what they're doing. They're not using these antiquated textbook formulas and things like that. They're using models. Nate Silver, who I think you've heard of, yeah. Nate Silver's like the only pollster that can actually call elections somewhat correctly. It's all he uses. All he uses is Monte Carlo simulations. It's like, why isn't the rest of the world using this?
Because they're dumb.
Well, it goes back to Davidson's question, how much effort does it take to make one? And not much once you're used. My Monte Carlo simulations have like one of 10 forms. Whenever I have to make a new form, the upfront load of making that new form takes a while. Like the one I had to do for 244 for their exam in 4 weeks. It took a while.
Form always takes a while.
Yeah, it's the upfront cost, right? But then you can use that to make other models similar, and that's when it becomes beautiful, right? Once you made your first iPhone, the iPhone 2 or whatever the hell they make next is not as hard as the iPhone 1, right? Once you've done something, you built the house. Now I want to put a room on it. Okay, well the house is there. Putting the room's not that big of a deal compared to the house itself. So it's kind of that idea. It's super rad. Anybody, you guys are more than welcome to keep any of the Excel spreadsheets that I use. Just send me an email, I'll send them all to you. Happily. And I encourage you to take them and run with them because you can do so much good math with just those. Aaron asked a very good question. The question you did. He asked about NBANG, which is the exclamation point in the project. And I misunderstood his question at first. He said, actually, what was the first question you asked?
I don't know.
Yeah, you do. It was, what's the point, or why is it the way it is? Yeah. Why is it the way it is? And I finally realized what he was asking. Why do we call it NBANG? Like N exclamation point? Like why that? Why not N smiley face or N? So I can't tell you why we use the exclamation point. I can't tell you that because I don't know the history of why we use that symbol. I mean, why do we use this symbol for adding? I don't know. I have no idea. Or this symbol for multiplying. Or this for dividing. I don't know the answer to these things. We just do. But I know why we do. And the reason why we do is because we get tired of writing the same thing over and over again, and that gives us a shorthand. I don't know why we call this for multiplication, but I know why we multiply, because we get tired of adding. I don't know why we call that for division, but we divide because we're tired of subtracting. And I don't know why we use that for NBANG, but I do know that we get tired of writing 8 times 7 times 6 times 4. And the word bang, it's so much more fun to say bang than factorial. Bang! For like 6 months when I first learned about that, I thought it just meant say the number louder. I didn't realize at first that it had a mathematical 8! I mean, it took me a long time. I shouldn't say 8, it was probably like 3 days or 3 minutes. But like, I had fun with it for that time. 12! Dr. Taylor's like, why are you yelling? I'm like, it says to yell!
This is exciting.
This is exciting! Anyway, it is very useful. Just so you know, friends, that's the symbol you use for the card shuffle problem. So when it says, you most likely have never seen the same shuffle again, that's because the number of unique shuffles is 52 bang. 52 bang is huge. I think I actually wrote it out in your project, didn't I? I think it's like 4 lines of text in like 10-point font.
Like 64 zeros.
64 zeros with a bunch of numbers in front of them. It's ludicrous. It's a ludicrously large number. And it's, when you see that, and you gotta realize, if you take a deck of cards and throw it down, that's one of those. Exactly. Then you start saying, if everybody on Earth had a deck of cards and shuffled them right now, you wouldn't even put a dent in that number, would you? I mean, think about it, right? It's like, it's my space thing. Good, thank you. So hopefully it was so enjoyable. Davidson, go.
Just about the factorials.
Yes, go.
The one that was from 6, 0 bang.
0, yes.
1,
Yes, and then why do you think it is?
I thought like looking at it in context, it was like NBANG is the number of times it takes to do something. So if you have 0 times, you can only do something 0 ways. The only way you can do it is to not do it.
Is to not, okay, so Davidson, just so you guys know, as long as you put something for why do you think 0 bang equals 1, you got 2 points.
Okay.
I was picking your brain to see why you, it doesn't make any sense, does it? It may. Now, the reason it made sense to me when I first learned it was I'm a huge fan of the band Rush. Huge fan. And they have a song. They have a song called Free Will. And one of the lines in the song Free Will is, if you choose not to respond, you still have made a choice. You still responded by not responding. 1. That's how it made sense to me. When you have no objects, there's one thing to do with them. Don't do anything. So, does that make sense? So that's how it made sense to me, the way Davis said it. That is not what you had to say. Who Googled it for an answer? Good for you! Good for you! Did anybody find the same answer we just said, or did you find something different?
You said that 0 is having an empty data set and there's still
There's still a set with nothing in it.
one set.
Good. That's actually a really cool way of looking at it because that expands to more than just 0. There's a thing called the empty set in like a pure mathematical sense. That the empty set is the subset of any other set. There's always a +1 because of that empty set. I don't like getting into it in 243 because it usually makes you guys want to leave. Then there's a base that's empty, and you build off of that base. So what 0 bang is, you haven't started building yet, so to speak. Yeah, Ian.
Does that sound familiar?
I think it's Free Will. Let's Google it at the break. I think it's
Probably
free.
right. I'm a very casual fan of Rush.
I'm a Rabbit fan. I'm pretty sure it's Free Will.
heard it on the radio.
Let's Google it. It's a fantastic tune. Fantastic tune. So anyway, hopefully it was not uber painful. I always have a hard time looking at the Facebook comments because they look very painful. But I have to remind myself, I'm seeing the people that are having a hard time. I'm not seeing people that aren't having a hard time. Does that make sense? So hopefully the ones that got their questions answered and look like you guys all helped each other really, really well. Thank you for that. It looks like they got their questions answered, and hopefully the rest of you were able to talk to each other or work independently and knock them out. I did see a couple of people say they couldn't get the F9 button to work. I apologize about that. I don't have any answer for that. Unless you're using a Mac, in which case I have an answer. You have to use something different, as Andrea has figured out.
No.
Yeah. Oh, it's just 9. Is it that simple?
Yeah.
Could you email me that? I'm going to add that to the project. If you're using a Mac, press 9, not F9. Thank you. I will take care of that.
F9 works.
I didn't realize it was that. F9 work what?
It works on mine.
On your Mac?
Hit the FN key and then F9 function, then F9.
We have 3 solutions. 9, that thing, and F9, F9.
We have a trinomial.
This is why I can't imagine working for an IT department.
You already do.
Seriously.
Free
I
will.
kind of do, right?
Rush, you mean?
Free Will?
Yeah.
Oh, it is Free Will. He's already Googled it for us. There we go. Tom Sawyer, another great tune, though.
I love Tom
Well,
Sawyer.
anyway.
Have you heard the remix?
Um,
This is good.
Yeah, this is why I came up for IT departments, because theoretically speaking, all of you might have a different platform you're working off of, behaving completely differently for every single one of you. And, you know, given enough resources, I'd love to sit with every single one of you and work with you while you're working through it, but of course that doesn't work. So, anyway, and I think this was part of the problem, is it will enable content buttons that show up every once in a while. Yes, trusted, I've used it for 15 years. All right. It doesn't like it doesn't trust it. Have we taken a look at this awful diagram last time? We did. Okay, and I think it made you want to vomit. But then hopefully we made it nicer for you.
I still don't get where we use it.
No, well.